Hello everyone and welcome to this video on registered organization of 8086 Metaverse. It's the series of lectures which I am carrying out for the students of electrical and electronics engineering doing the course on microprocessor and microcontroller systems. So this would be the third unit topic, and we'll be having a discussion on what are the different registers of 8086 microprocessor, how the register organization is being classified, how we are going ahead with the register organization. First of all, once again repeating to the concept of 8086 microprocessor is a 16-bit 16-bit microprocessor. So when you are having 16-bit microprocessor, you would be having 16-bit data bus, and to take up this data or do some arithmetic operations over there, we'll be having mostly 16-bit registers. So overall here in your 8086 microprocessor, you are having all the registers are of 16-bit registers. So these registers are being classified into different categories, and when we look at into the register organization of 8086, this looks like a very powerful register organization. It's having all the different categories of registers. So the first category is general purpose registers or general category registers. There are 4 general purpose registers. All these are 16-bit registers. The same registers can be used as 8-bit registers also. So when you are using them as 8-bit, it is not compulsory that all the 4 can be used as 8 bits. You can use any one of the registers as 8-bit. The other registers you can use as 16-bit, or all the 16-bit registers can be used as 8-bit. So the maximum number of 8-bit registers you can have it in 8086 is 8, because 4 registers can be split in 2 registers. We will be discussing. Second category is about the segment registers. There are 4 general purpose registers, 4 segment registers, and here you will be having 3 pointer registers and 2 index registers. Totally 5 registers over here, and 1 register, 16-bit register is a flag register. All put together, you will be having total 14 registers in your 8086. How much? 14. 4 general purpose registers, 4 segment registers, 3 pointer registers. This would be 3 plus 2. 3 pointer registers, 2 index registers, which would be 5 registers over here, 1 flag register. All put together 14 registers. How this is used in your microprocessor? What is the use of these registers? We will be discussing one after the other. And the first category is general purpose or general data or general purpose registers. Mostly we will say it as general purpose register. As it is been holding the data, we will say it as a general data register. There are 4 registers named as AX, BX, CX, and DX. So AX is called as an accumulator. It is a 16-bit accumulator. And all these registers, when you go for AX register, BX register, CX, and DX, these registers can be split into 2 parts. Like AX can be split as AH and AL, 8 bits. Or combination of these two can be a single register called as AX register, which is 16 bit. And this is an accumulator of 8086. When you go for accumulator, what are the different operations or what you will be having additional advantage of an accumulator? The first one is like it stores the results. It stores results for some of the instructions. Compulsory, it is an source of a result or a destination is your AX register. For some of the registers, like multiplication is there, like division is there. For them, AX is the destination. And likewise, we are having some more instructions like changing a word byte to word. It takes into consideration only the AX. When you go for negation also it will take it. Like that way, you will be having lot of instructions that would be indirectly or directly will be related to the AX register when you are having 16-bit. And out of this one, AL can be used as 8-bit accumulator. If you are having any 8-bit operations or other, then AL is considered as an accumulator, not AH. AL is considered as 16-bit accumulator is nothing but AX. Similarly, for using data values or for storing the some offset physical addresses, we'll be making use of the another register called as the BX register. BX register is used for storing the offset addresses or some data values. When you do for some mathematical one register in your BX register, we can use that for storing, giving the offset addresses like exchanging the instruction is there. It also refers to this BX register. Like this way, specifically for some time it is used. That is the purpose of it. Next one is that when you go for third register, CX is also called as the count register. Count register, why the name is given as a count register is that usually when you go for loop instruction, it's an instruction called as loop. When you want to repeat the loop, how many times the loop has to be repeated? The times the loop repeats, number of times the loop repeats is should be equal to the CX value. CX value is nothing but the number of times the loop. So this is about the CX register. We are having one more register called as DX register. This is called as the data register, and this is very specifically used for storing the data, general purpose data. But here, it has one important point over here. When you are going for input-output operations, in-out operations, when you go for in-out, the general addressing is being given by this DA system. When you want to go for generalize the addressing, then you will be using as DA system. Next comes is the segment register. So overall here, I will have just a small picture overview of this one. In your 8086, you will be having what? Total of 1 MB of memory. Out of this 1 MB of memory, we will be 1 MB of segments. Each segment is of what? 64 KB. So the starting address of the segment is given by a segment register. It is given by a segment register. So initially, when you are writing a program, obviously you need to define what are the segment registers available. You need to define those registers, and then you can use those registers. Basically, we are having four segment registers. The number one is core segment register. Second one is data segment register. Third one is extra segment. Fourth one is stack segment. So these registers related to the segment starting addresses. Like core segment will hold the starting address of the segment. Starting address of the core segment. Similarly, data segment is used to store the starting address of the segment. Extra segment register is used for here. So the starting address of the extra segment. Stack segment is the what is the use of the core segment? Core segment is used for the sorry, data values. Extra segment is also for stack segment is used to store addresses and addresses. Coming to the next one, category is pointer and index registers. There are three pointer registers. These pointer registers may be the used to store the offset addresses in the like we can see these two IP and SP. These two are fixed to instruction pointer is used to code segment. Instruction pointer is fixed to an offset in a code segment. So what is an offset? Suppose this is the code segment. The code segment starting address is something over there. That is the original code segment register. So here at this mark, the value of the code segment will start at 000. It ends with 10. So this is called as an offset address. Within the segment address, it's called an offset address. So this address is being done by one of the offset registers. Like for code segment, we have IP. For the data segment, we will be having BP. For the static segment, we will be having SP. So this will be holding the offset address. Similarly, when you are going for the data values, if you want to store the data values, the offset data values of data segment and extra segment are stored in SI and TN. These are used for storing the offset values in your data segment and extra SI and TN. The last register is a flag register. Once again, a detailed description about the flag register given over here. Flag register is a 16-bit register. Out of the 16-bit register, 9 flags are defined. How many? 9 flags. Out of these 9 flags, 6 are functional flags. Depending on the condition, the flags are set or reset. 3 are machine control flags. Machine control flags in the sense it is in how have been given the machine control. You have system control and machine control plans. So this is about the migration of data. Overall here, this is the total register organization of 808. So here, in once again giving a summary of the you will be having only the complete registers or complete registers for general purpose registers and for register for sorry, 3 are pointer registers are index registers. One is flag register. So this is about the flag register organization of 806. And if you are having any questions, you can text me. I can respond. Thank you.